No, ma'am. Thank you.
Good afternoon, everyone. Um, an American novelist, Thomas Berger, had once said that the art and science of asking questions is the source of all knowledge. I absolutely believe in this, and more importantly, the part of art and science of asking questions. I think that asking questions is very much an art because no matter how great a subject matter expert you might be, after all, how you ask questions or how effectively you ask questions, that is very much of a skill that you have to nurture and build over the years in terms of your body language, your tone, the kind of remarks that you make before and after asking questions. It is definitely a science because there has to be a lot of logical and rational thinking in structuring your questions, in sequencing your questions. So that is basically what we are going to talk about today. That is, uh, how actually can we ask questions in the class effectively? I think as teachers, as educators, we are asking a lot of questions to our learners in classrooms. We do ask a lot of questions, but sometimes if we don't structure them properly, or maybe the way we are asking the questions is not very effective, then the whole purpose can be defeated. So let me begin with my presentation. Now, firstly, what is the importance of asking questions in the teaching learning process? Now, in today's times when we are talking so much about learner centric teaching, of course, it is very, very important that we involve our learners in fruitful conversations. That is very, very important because teaching is no more a one man show where the teacher just enters the class and shares the lesson and leaves the class. We have to involve our learners in the process to make it effective, and that of course is the first and foremost importance of asking questions in the class, in the teaching learning process, because it stimulates conversations, it encourages discussions, not only between the learner and the teacher, but also among the learners, which again is a very, very important aspect in the whole thing. Secondly, it enhances classroom engagement. Now, the reason why I mention discussion and engagement separately is that very often we tend to consider these two things synonymously, that any particular child in the class who is speaking is also engaged, but that might not necessarily be the case. I think as teachers, we have all come across those children who are very much engaged in the class, who might be very much involved in what is going on in the class, but not everybody is equally willing to speak out, or because children are all unique, they are all different from each other. So we do have these children who are very involved in the class, but they don't talk a lot. So when you are questioning, it also helps to engage these learners who might not always be conversing with the teacher or within the peer group, but definitely they are engaged. So when we ask questions, these are the children who actually start thinking. And that is actually what brings me to the third point that I have mentioned over here, that it fosters creative and critical thinking. Now, this is very, very important because when we teach a topic, any topic in science that we might be teaching in class, it is very important that uh, we help the children to think, because we are introducing maybe a concept which is absolutely new to them, a concept which they are hardly aware of. So until and unless we help them to think, or rather the way we are teaching helps them to think, it will be very, they kind of lose the point. I think they will start thinking, why on earth am I even learning this topic? So until and unless we lead them in that path of thinking and trying to reflect and trying to relate what they are learning to the kind of observations that they make in real life, uh, I think once again the whole point of it is lost. And of course, the last but not the least, of course, the most important aspect of asking questions is, of course, to have some clarity about how much progress the learner has made. Now, it need not always be an elaborate question paper or an elaborate worksheet that I have to give to the learner to assess how much she or he has learned. But even maybe at the end of the lesson, when we ask them simple questions, we kind of, as teachers, we start having an idea, we start getting an idea as to what extent the learning outcomes have been achieved. So that, of course, is, I think, what comes to our mind first when we speak about questioning, when we talk about questioning or the importance of questioning. Now, the next thing that we have to ask ourselves is that as science teachers, why is it all the more important to ask questions? I think as teachers of science, the sole purpose why we teach is to enable the children to think logically, to ignite that curiosity, that why does this happen? Something that I have observed, how can I explain it with the help of science? So questioning definitely is indispensable in science classrooms. Now, as I said earlier, when there are questions being asked in class, we are actually involving our learners into a fruitful discussion. So, very often what we observe is that when a healthy conversation is going on within the classroom, learners themselves start sharing observations, things which they have seen, things which they have experienced, things which they have come across. So these can actually be very, very effective leads which can help us to start the topic. Like, say, for example, it could be a very simple question like, when we put up wet clothes for drying, what do you observe? Does it dry faster during monsoons or during the dry winter months? So, before maybe we jump into the topic of what are the factors that affect, say, the rate of evaporation, questions like these can actually help learners to relate the topic with the simple observations that they have made. And in the process, once one example is put forward, they will themselves start sharing their own observations. They will themselves start talking about the things related to the topic that they might have experienced, they might have observed, or they might have come across. So that is, I think, one of the foremost reasons why questioning is imperative in a science classroom. Once the observation part of it is done, that automatically leads us to the next question, that whatever I have observed, or maybe some results that I may have come across somewhere, why does that happen? So interpreting the results and the evidences that I have come across, like, say, for example, in optics, when we are teaching them sign convention and we are talking about the power of lenses, positive and negative signs, what kind of lenses will have positive power, or concave lenses will have negative power. So these kind of things are ideas which they relate to, because when they go to the doctor and the doctor tells, okay, your power is plus 2.0, or your power is minus 1.75, or whatever it is. So when they are trying to interpret these results, they are actually not learning it mechanically. They know that, okay, this is what I have observed and this is how I can interpret it. So that helps them to make an immediate interconnection between what they have observed and what they are learning, which again is a very, very essential aspect, particularly when it comes to teaching science. Next is making inter and intradisciplinary connections. Now, once again, this is very important. it is essential that we tell our learners that all the different topics or all the different subjects that they are learning, they are not really compartmentalized. It's not that one subject is in a watertight compartment and another subject is in another watertight compartment. So when they start making these kind of interdisciplinary connections, it, I think, gives them a very good way of being able to join the dots. Like, say, for example, they might be studying about tides in geography. Once again, maybe in physics, when we are talking about gravity and we are talking about the gravitational forces among the different celestial bodies, between the sun and the earth, between the moon and the earth, etc., we can always bring in that concept of tides and tell them that, okay, you have learned about tides in geography. uh, you've learned about high tides, you've learned about low tides, so on and so forth. Now can you try to relate the idea of gravity to the idea of tides that you have maybe learnt in geography? Or, say, for example, even within the discipline, say, they have learnt about density, they have learnt the definition of density as mass per unit volume. But maybe later, when they are studying about convection currents in heat, and they are trying to figure out that how a convection current is set up, it actually helps to ask them that how can you relate the definition of density that you have learned earlier to how convection currents are set up. Like, say, for example, when it gets heated, it expands, the volume increases. So density being mass per unit volume, the density decreases, and so on and so forth. So this actually gives them this way of joining the dots, and so they will learn everything in a much more fruitful manner, rather than thinking that, okay, this is one separate subject, this is one separate topic or separate chapter. That actually is something that we can do away with. Next, and very important, is refining ideas. Once again, I'll come to this in greater detail in the later part of my presentation. That is, sometimes when children give answers, when we ask them questions and when they give answers, um, it's better that we don't tell them that, okay, this is not right, but rather what we can do is that through our questions we can try to refine the ideas that they already have. Like, say, for example, if uh, they are asked that, what do you mean by reflection? Normally, the kind of response that children will give is that when light from a source, it strikes an obstacle, and it is sent back to the same medium, that is what we call reflection. So instead of telling that, no, this is not the technically correct definition, we can ask them that, okay, could it be any kind of obstacle? Could you give me a few examples of the kind of obstacles from which reflection can take place? So this, again, that brings me to what I had started with. This is basically the art of questioning that I was talking about in the beginning, that we need to understand that every child has to be, we have to do a lot of hand holding, because not everybody is going to get to the point right in the beginning. So through our questions we can do that hand holding. And finally, of course, developing new perspectives. I think this is not just for the learners, but uh, the teachers also have something for them in it, because very often it happens that, particularly when we are doing problem solving kind of exercises, maybe you as a teacher has thought, you have thought of solving a problem in a particular manner, and maybe some student comes up with a method which, as teachers, we think, oh, this is a wonderful method, this is much, in fact, this is much better than the method that I had thought of. So I think that's something that, I think as teachers we have all experienced at some point in time. Now, having said that, uh, effective questioning is something that I have been talking about right from the beginning. And the reason I think it has become all the more important today is because we are living in a digital era. And of course, we all know about all these artificial intelligence powered platforms like ChatGPT, etc., where it's very, very easy for the learners to, they just type in the question and they'll get a perfect answer. So actually, until and unless we refine our questioning techniques, I think it completely loses its point. So we have to ask them questions which, again, I'm harping on the same point again and again, which will help them to think, which will make them think, which will push them to think in terms of the experiences that they have acquired, or maybe questions where they have to apply their common sense, or maybe questions where they have to apply their understanding. So that actually is very, very important. And as I said, it's all the more important in today's times, because if I just tell them that describe an experiment to investigate Ohm's law, it's not a big deal at all. They'll just write it, they'll just copy it from somewhere. But then these are not the kind of questions which, where they can share something from their own experiences. So again, that is what makes effective questioning all the more important. Now, having said that, I'll move forward to what could be the different kinds of questions that we could ask in a typical science classroom. Um, Open questions, probing questions, closed questions, reflective questions, and hypothetical questions. These, broadly speaking, these could be the five different types of questions that we have. And of course, there could be different kinds of questions under each category, but it is very important to sequence these questions in a logical manner. So as I said right in the beginning, that is where the science of questioning comes in, that you have to go on with your questions in a very logical and step by step manner. And you should not be jumping into something without having a clear idea as to how much the learner has actually learned. Now, open questions, I'll just talk about these different kinds of questions briefly. Open questions, these are brilliant conversation starters, particularly when we are introducing a new topic. These kind of questions can be really helpful. And, these are the questions which actually put the learners in that comfort zone, because these questions, uh, they don't really have a specific correct answer. So here I have shared some examples of what those questions could be like what do you know about, or tell me something about, or what do you notice. Like suppose we are if we are introducing the topic of electric current in the class, we can just ask them that what is your idea of electric current. So when I ask an open question like this, the children know that okay, the teacher is not really looking for a specific correct answer. So they start sharing their ideas, and you will always find that there will be at least two or three learners who will come up with ideas like it has something to do with the flow of charges. So maybe that you could use as the hook line of your class. Maybe you can write that out on the board, that okay, flow of charges. So these questions could be a great way of starting our lessons. Excuse me. Next, we move on to probing questions, which actually takes us a step further, where maybe, as I mean, if I go back to my earlier example, what is your idea of electric current? Suppose somebody tells me it is the flow of charges, so maybe I write that on the board. Then I move ahead and ask, what kind of charges? Or what do you know about these charges? Maybe somebody says that these are electrons. Okay, I write that out again. Anything else that you know about electrons? So probing questions could actually be a great way of differentiation, of bringing about differentiation in the class as well. Because uh, when I'm asking for probing questions, these are actually more focused questions, and we are actually looking for more detailed information from our learners. So while open questions actually are being addressed to all the learners in the class, probing questions do help us in bringing about a little bit of differentiation in the class, because maybe those children who are more capable of critical thinking would be the ones whom we could ask these kind of questions. Closed questions, of course, are the straightforward ones. So that mostly would come towards the later part of the lesson. We don't usually start with closed questions right in the beginning of the lesson. And once we have maybe a certain portion of the topic at least has been taught, then it is very effective to ask closed questions, like straightforward questions where there is a specific answer. Like I've shared some examples over here, say statement of a law, or what is the atomic number of something, or F equal to ma, what do these symbols stand for, things like questions of that sort. Now, these closed questions, as I was mentioning earlier, these also could be used as effective tools of very short and quick formative assessment. So maybe towards the end of the lesson, if I ask them these questions, I would be able to form an idea as to how much of the knowledge has actually been transferred, and how much the learners have actually been able to acquire. So, closed questions in most cases are not the questions which actually foster a lot of critical thinking, but then these can be very, very effective as tools of quick and short formative assessments. Next, we come to reflective questions. Uh, Now, reflective questions actually need not always be uh, very specific questions, but once again, it is these are the kind of questions where we are trying to inculcate the higher order thinking skills among learners. So usually we associate reflection with the four C's, that is connection, continuity, challenges, and contextualization. So reflective questions could be like, maybe when the learner has answered a question, I can ask somebody else that, do you agree with what she said, or are you sure about what he said? Or suppose maybe in electricity, we are trying to solve a complicated circuit, so we could ask that, is there any other way that I could go about solving these problems? So all these kind of questions actually lead the learners firstly to think, and it also crystallizes the concept, because normally when we are teaching, we are talking about a lot of things in the course of our conversation with the learners. So it is very, very important that beyond a certain point, maybe when we are reaching the end of the lesson, we start helping the learners to assimilate what they have learned in those 30-35 minutes. So reflective questions could be actually a great way of doing that. And finally, hypothetical questions, which I think is absolutely imperative when we are teaching science, because yes, these are the kind of questions where we pose absolutely imaginary situations, but then these could be great questions when we are doing problem solving. Like, say, for example, those problems in mechanics, like you are standing on a raft which is flowing upstream, and so, of course, this is a completely imaginary situation, but then um, it would help the learner to think of a lot of things, the directions of the vectors involved, the ideas of relative velocity, or say, for example, a circuit. We have given them a circuit diagram. We could ask that, okay, what if this part of the circuit was replaced by a parallel circuit instead of a series circuit, or the other way around? So all these are, as the name itself suggests, these are all imaginary situations that we are talking about. But then it is very, very important that we ask these kind of questions in any science classroom, because these are the questions which actually develop the investigative skills in learners, or maybe later on, when they move on to do experiments, that is that abstract thinking and that investigative skill is very, very necessary, and it's very important that we ask these questions to uh, learners, particularly in science classes. Now, having said that, this was more what I have spoken about so far was basically about the science of questioning. That is, there should be a logical sequencing in the way we proceed with questioning. But then, as I said in the beginning, that questioning is also an art, and there are certain things that we need to keep in mind when we are asking questions. First and foremost, we should not be rushing with our questions. We have to let the learners think. We should keep in mind that it's a new topic which the learner is learning, and she needs to think before she answers. No hands up. I have experienced it as a very, very effective technique, because usually when we ask questions and the children raise their hands, it'll always be the same set of children who will raise their hands, and they are the ones who are always willing to answer. So rather than that, we as teachers could try to bring about some randomness, like maybe we just randomly call out their roll numbers. Roll number 37, answer this question. Roll number 10, answer this question. So the children are also alert, and and in the process, we can make sure that each and every child in the class is involved in the process of uh, the question answer, that is the question answer sessions, may I say, if that is going on in the class. No opting out, because some children have this tendency, they'll simply say, I don't know the answer. Okay, you don't know, fine. Anybody else who knows? Do you know? Yes, maybe that child says the answer. Okay, now you repeat what he said. So the child, we don't let the child just tell that, I don't know the answer and get away with it. We should not be allowing anybody to do that, because at the end of the day, we as teachers know that when they are saying an answer, that is something which is very, very effective, that helps them to remember what they have learned and what the answer to a particular question is. Another very good way of doing of asking questions could be that, we could, maybe somebody has said an answer, somebody else wants to refine that answer, and after that answer has been refined, maybe by another student in the class, or maybe by the teacher, we can again ask the child, okay, now you tell me the complete answer. So once again, that kind of helps the child to process what he or she has said in the answer better. Think, pair, share is actually a very good technique, which particularly works well with those children who are a little introvert, who are a little shy, and the ones who are not always very willing to speak up. We always have those children in class who we know are involved in the class, are engaged in the class, but then they are not the ones who will raise their hands or, talk a lot. So maybe we can form the children, having groups of two or three, wherein we can ensure that maybe a particular group has a child who's not very vocal, with another child who is quite vocal and likes to talk. So when they come together, firstly, they can think. Secondly, within the group itself, they can pair up and exchange their ideas. And then we can have all these groups share their ideas with the entire class. So that again is a very healthy transaction of knowledge, a very healthy transaction of information that can take place.
Miss, was sorry to interrupt you, ma'am. It's 30 minutes now. Can we take the questions? We have 11 questions lined up here, and
Okay.
because of the time crunch too. I'm sorry to
Okay, no problem, no problem. Okay, thank you. I'll just stop sharing.
Sure. Thank you. Can you expand your camera screen so that it will be full screen now? Can you do that? Otherwise, leave it, ma'am. No issues. No issues. So, actually, like you have covered, I was going through the questions and you have covered almost all, where you spoke about different kind of questions, open-ended, close, probing questions, reflective questions, everything. So, but I would like to repeat this, or read out all the questions to you. The first question goes like this. What qualities make a question in science effective or meaningful?
I think, as I mentioned in my presentation also, the first and foremost thing is the context. Because in science, since it is a very interrelated discipline, we have to keep in mind that the question that I am asking should be contextual. And because many a times it happens that maybe I'm asking a question from optics, but then it also requires some knowledge of mathematics which the child might not be having. So that is something that I really need to keep in mind. Like, say for example, if I'm asking them about refractive index, of course there are two ways that we can define it. We can talk about refractive index in terms of the speeds of light in a pair of media. We can also talk about it in terms of the ratio of sin I and sin r. So I have to keep in mind that, is the child aware of the trigonometric functions? Has she studied about it in math? So that is something which is very important. Secondly, any question which is asked in a science classroom, the ultimate objective of that question should be to help the child think. It's of course, knowledge is important, cognition is important. I'm not saying that we'll never ask them to state a Hooke's law, or we'll never ask them to define the optic center of a lens. Of course that is important, but then it is equally important that children should be able to think. Maybe we have to tell them that, okay, it's absolutely okay if your answer is not correct. In fact, I had thought of telling this in the last part of my presentation. I was nearly done anyway. That we have to bring the children in that comfort zone, because normally children tend to think that, okay, science is a very scary subject. Science and maths, are kind of monster subjects for most learners. So they think that, okay, no, I'll not answer. What if I'm wrong? So it is very, very important for science teachers that when they ask a question, they should bring the children into that comfort zone, and we should tell them that, I'm just asking you to share your ideas, I'm just asking you to share your thoughts. It's perfectly okay if your answer is not technically correct, because that's the way you are thinking, that's your perspective. So please feel free to share. So I think these are the three things that we need to keep in mind.
Right, ma'am. So could you provide an example of a well-crafted question and explain why it's effective?
Could you please repeat your question? Sorry.
Yeah. The audience wants to know, one, educated posted, he or she wants to know, could you provide an example of a well-crafted question and explain why it's effective?
Okay, so I think I will go back to the topic, the example that I was mentioning earlier. That suppose I have started teaching electric current in the class. So maybe the first open question that I can ask in the class is, uh, what do you mean by electric current? What is your idea of electric current? Usually, in my experience, children will usually come up with examples. Electric current is something that lights a bulb, that makes a fan run, and so on and so forth. But then, as I said, there will be at least one or two children who will give you that basic hook line, so to say, that yes, it is the flow of charges. Okay. Next step would be, what are the charges that we are talking about? Maybe somebody tells you electrons, or even if they don't tell you, even if you don't get that answer from them, okay, do you know of what are the charges that you know of? Okay, we have heard that atoms are made up of electrons, protons. Okay, do you have any idea which of these charges is responsible for electric current, electrons. Okay, whether if you don't get an answer from the learners, you have to give that push. That is also very important. Now we come to the other part of the line, that is the flow of charges. Okay, flow. What do you mean by flow? Charges moving around. What do you think makes the charges move around? Okay, it will need energy for that. Where do you think this energy comes from? There has to be a source in the circuit in the form of a cell or a battery or some kind of power supply. So, all the questions that we ask, it's not necessary that everything, all the information that we are looking for have to be stuffed into the same one question. Rather, it's always better when we break up the question into small parts, because that helps the learners actually to think in a step by step manner, rather than when you directly ask, okay, tell me everything that you know about electric current, tell me what is the function of a cell or a battery in an electric circuit. The learner is clueless. She doesn't even know what we are talking about, what charges, why are they moving around, what am I actually looking for. So in this way, if we break down the questions, that is, I think, more effective. So it's not just one question here, but it could be a series of questions which we ask in a sequential manner, and that is basically the science of questioning.
Yes, ma'am. I would like not to repeat the same questions like what you have already answered, ma'am, in your session, not the questions you have already explained through your slides. So I would like to move on to the next question. It is related to the research part. Can you share some tips for students to develop their questioning skills when conducting scientific research?
I think it is very effective when we let the children do things by their own, because like, I'll just give you one small example. uh, in the middle school, when we introduce the idea of sound and the characteristics of sound, pitch, loudness, etc. Okay, those are the classes where they are not really doing a lot of high tech research, so to say, but we could have them involved in simple activities involving simple things, where they do things by themselves. So, say for example, I mean, this is something that I use a lot in my sound lessons, that make a simple stringed instrument by yourself, maybe use a shoebox, use some rubber bands, and you try and explore, pluck the rubber bands, vary their lengths, vary their tightness, vary their thickness, and see what you hear, how that changes. So I have just given the cue. I have just told them that in what way they have to move ahead, or along which path they have to move ahead. The rest of the questioning they have to do. So they have to figure out that, okay, firstly, what are the variations that I need to do? Secondly, what are the things that I need to observe? Thirdly, how do I infer my observations? So when they are themselves allowed to do that, it becomes very effective. So it's, firstly, in science, it is very important that we encourage the learners to uh, handle things which, I mean, handle real life things. It's not about write a 4-page report after doing some research on some complicated topic. As I said, it makes no sense actually, because they'll just open ChatGPT and prepare a nice report and submit it to you the next day. Rather than that, when they are dealing with real life things, and we have to tell them that, okay, this is the sequence, this should be the approach of your thinking, but then think for yourself, make mistakes, it doesn't matter, but question and try to answer your questions by yourself. And sharing of information is also another very, very important uh, aspect in the science classroom, because every person has his or her own way of thinking. So that is what I was talking about when I was mentioning about perspectives, because the same thing, three people might be thinking in three different ways. So when they share their ideas, uh, and in the process they can start questioning each other also. So the whole idea is to keep things as real as possible.
Okay. So, what are the potential challenges or misconceptions that students might face when trying to formulate questions, and how can they overcome them?
um, Firstly, you are asking about students questioning.
Yes, ma'am. So, what might they face? What kind of challenges they might face when trying to formulate questions?
Hmm. One very common experience that I have had is that now, of course, since we are living in an age of information explosion, they hear about a lot of things. They learn about. I'm sorry to. I stand corrected. They don't learn. They hear about a lot of things, and uh, things which might sound very fancy to them, so they start thinking about those things without knowing the basics, without having clarity about the foundations. I'll give you one example. Say, for example, when we introduce the ideas of gravity and gravitational forces in the class, very often I have my kids asking, "Ma'am, what is a black hole?" Okay. So, uh, a child who has no idea about gravity, who's just started learning about gravity or gravitation, is asking about a black hole. So, this I think is the major challenge that we need to overcome in today's times, because they hear about a lot of things, they see a lot of things, and without knowing the basics, without knowing the foundations, they are tempted to those kind of ideas. Another very important thing is, another big challenge I would say, is that children nowadays are watching YouTube videos and all these things all the time. So even if maybe the so called educational videos that you get to see on YouTube, all these experiments and 25 amazing physics experiments, okay, very good, but then in those videos, of course, we know, I mean, as adults we all know that how those videos are made, and in 2 minutes they'll show the weirdest of things happening that one can even imagine. So they tend to think that, okay, experimentation is very easy, which we all know is not. So even when they are asking questions, or that is the kind of space where they are residing in, they think that, okay, it's very easy, I'll never make a mistake when I do an experiment. Oh, why did I make an error while I was performing this experiment? So these are the idea, these are the challenges, I think, which we as educators are facing. And it is important that we bring them out of that. We have to tell them that a YouTube video, a 2-minute YouTube video maybe has been recorded for 3 hours, so it's absolutely fine if you have made a mistake. Or when they ask about the black hole, we can tell them that it's good. We have to encourage them also. I cannot just tell them on the face that, okay, forget about it, you are not even eligible to speak about it. We are not going to say it like that. We'll say that, okay, it's good, I'm happy that you have heard about it, but there are a few things which you need to learn before you have a clear idea about black holes are. So yeah.
Yes, ma'am, absolutely right. So, keeping technology aside, we have already discussed about, you have mentioned about ChatGPT and how it's like very easy, but again, yet that the child will not be able to learn the depth of it, the depth of the topic, because it's like, it's made and just given to you and you are submitting. So, what resources or books would you recommend for educators or students who want to enhance their skills in asking meaningful questions in science, ma'am?
Uh, See, the first thing is that, of course, I would never say that we have to completely do away with technology. That's not possible in today's times, and that's not
Right,
logical, also.
right.
So, what is more important is to learn how to use the technologies fruitfully. that I think itself could be another 2 or 3 sessions as to how we can fruitfully use technologies. But anyway, to answer very quickly, I would say that nowadays we do have a lot of simulations, science simulations, which are available. Like I think Colorado University, they have a great site where you find a lot of simulations on a whole lot of topics. So that actually is something that, in fact, as a teacher of physics, that is something that I use a lot, because there it's not that they are getting access to ready-made answers. Also, there you can have them deal with things which might not always be possible to carry out in a class. Say when I'm teaching atomic physics, these kind of simulations come very handy. So that could be a very good way of using technology or incorporating technology into how you transfer your lesson. And again, I would go back to the same thing that I have been repeatedly mentioning: give them real life experiences. That is very, very important. It could be something very, very simple. You might be just using a glass of water and a straw, and you can make a small tiny you can just prick the straw, make a small hole on it, and ask the child to suck water through the straw. And okay, why are you having difficulty in doing this? Introduce the idea of atmospheric pressure. So these are all simple things. We don't really need a lot of resources for these also. So even in schools and classrooms where we might be having to deal with limited resources, these can actually be very, very handy. And yes, technology, if I have to incorporate, as I said, to begin with, these using these simulations could actually be a very good way of doing that.
Great to know, ma'am. That's all for the question answer round. And we have to end the session now because of the time crunch too. School Journal of Education and schoolreformer.com. Thank you for the talk and for patiently answering all the questions, ma'am. We also thank the audience for participating in the event. We will end the session now. Do you have to say anything else?
I would extend my heartiest thanks to school reformers for giving me this opportunity, for giving me this platform, because in any case, I think you all are doing a great job, because it is very, very important that as educators, we keep on collaborating, because teaching is it's an evolving process. It's not that okay, I'm an experienced teacher, I know everything about teaching. That I think is something that no teacher can claim. Even somebody with 30 years experience still has so much to learn. So I think you people are doing a great job, and thank you very much for giving me this wonderful opportunity. Thank you.
Thanks a lot, ma'am. Have a great day. We will end the session now.
Thank you.